Hi, this is Miss Howell. We're going to go ahead and get this video done for you guys today. This is the peripheral nervous system part 2, so the second half of module 9, and we're going to focus on the general and the special senses today. You've got your guided notes, so look for the red words on the slides and those items marked with a star so that you'll know where you're headed for your next test. General senses are also called somatic senses because they're located in your skin, muscle, and tendons. And there are two types of somatic receptors. There are cutaneous receptors, and those are located in the skin. Cutaneous refers to the skin. So I'm not going to read through all of these, but I want you to pause the tape at this point and look at each one of these, fill in the red points on your slide. But you do need to notice the red stars and make sure that you study these. So you might want to make some flashcards for each of these 6 so you'll know what their name is and what exactly they do. The second type of receptor is proprioceptors. These are located in the muscles and the tendons. They're important for informing your brain about the position that your body is in. So these include your muscle spindle, which responds to the stretch of a muscle. And remember, where your muscles are relaxed, that is when the muscles are stretched. And then the Golgi tendon organ is another proprioceptor that responds to tension in the tendon. And remember, the tendons are what attach a muscle to the bone, and when there is tension in that tendon, that is when the muscle is contracted and it's pulling the tendon toward the center. So that tension on that tendon travels on that receptor to the brain to let your body know where your position is in different parts of your body. Okay, now we're going to move on to the special senses. So those were general, these are special. The first one is your sense of smell, and it is also called olfaction. Like your olfactory glands, olfaction is the name of the sense of smell. It's one of the most poorly understood processes in the human body. There's so much going on that they haven't figured out yet. The threshold for smell is very low. So what does that mean? We talked about threshold stimulus before. So what does it mean if the threshold for smell is very low? Well, that means that it doesn't take very much stimulation at all to trigger an action potential. So a very faint scent is all that's required to trigger an action potential to head to your brain and alert you that you can smell something. After the olfactory hairs are stimulated constantly, when you're receiving a scent for a very long time, those action potentials don't send anymore. So you don't seem to be able to smell anything anymore. Have you ever noticed that a perfume or a cologne or a body spray, especially you girls, that you've worn, you feel like you have to put it on more and more often because you think that the smell's gone away? Well, it's not that the smell's gone away. It's that your nose got tired of smelling it and it kind of shut down and quit sending action potentials to the brain. So every time you keep putting that on, you're really making it strong for everybody around you that, is with you temporarily. But you're with yourself all day long, right? So to be smelled, a scent must also be airborne and volatile and partly soluble in fat and water. There's a star by that, so you need to understand all of these things. So for a scent to be able to be smelled, for you to be able to notice that it's there, first of all, it has to be airborne, meaning it has to be particles floating within the air. Then it has to be volatile. So define volatile. So volatile is any substance that can evaporate into a vapor so that it becomes airborne. So those kind of go hand in hand. They also have to be partly soluble or dissolvable in fat as well as water. Why do you think that's so? It's because your olfactory glands and hairs that trigger these action potentials that go to the brain are located in the very upper part of your sinuses, up in the upper part of your nose. They're in the superior part of the nose. So if you sniff to try to smell something, that's helpful because it's helping to pull those molecules that are airborne, volatile, soluble in fat and water, and they pull them up into the nose. And they have to be soluble in fat and water, and this sounds gross, but it's because your sinuses have mucus in them to protect the area And mucus is mostly water, and you've got some oil there. So that makes smelling possible, as if the thing you're smelling is something that can be dissolved in fat or water. Let's move on to the sense of taste. This one has another name as well. It's called gustatory sense. Gustatory. Okay, there's a term you need to know. It's called papillae, and the papillae are the tiny bumps on the surface of your tongue, and those are associated with the taste buds. And did you know that young children have taste buds on more than their tongue? They tend to wear out over time as we age, but where do you think those are? Well, they're on the palate, which is the roof of your mouth, throughout the inner part of your lips, and in the back of your throat. So when you were very young, you had taste buds in all those areas of your mouth. So taste buds look like a flower bud if you were to zoom in on them, and they can only taste food that has been dissolved in saliva. Have you ever had a time in your life where you were sick or didn't feel well and your mouth was really dry? Maybe you had a bad cold and you took a antihistamine like Sudafed or Allegra or something. Not Sudafed, but Allegra or Claritin or Benadryl. Those antihistamines tend to dry out your mouth. Well, when your mouth is dry, you don't produce any saliva. If you eat, food doesn't have much taste. And it's because the food needs to be dissolved in the saliva, and then the chemicals in the saliva, after the food is dissolved, are what bind to the receptors within your tongue, and they release neurotransmitters, stimulating action potentials that move to the brain. And you have four sensations of taste, and your taste is also associated with your sense of smell. So if you can't smell things very well, you're not going to be able to taste very well either. So on your tongue, you have different locations that are able to taste different parts or different kinds of food. So sweet is on the tip of your tongue only. So licking an ice cream cone, you can taste the sweetness of that. Salty is just behind that, and actually salty can be included on the tip of the tongue as well. So salty is the whole area from the tip to partly back on the sides of the tongue. And then behind that, but not in the front, only behind that, on the sides of your tongue is sour. And then in the very, very back of your tongue is bitter. So you don't really know something's bitter until you're about to swallow it. And that kind of stimulates the gag reflex. Like your sense of smell, there's an adaptation of the taste receptors. Just like we said, you can get used to a smell and you no longer smell it. Well, that can happen with taste too. So if you've ever started out eating a meal that was real spicy and you're like, oh my gosh, this is so spicy, but by the end of the meal, you're just eating it like it's no big deal. That's because your tongue no longer senses that taste as wildly spicy anymore because your body has gotten used to it or adapted to it. Foods don't taste as good when you have a cold. So why do you suppose that's true? Well, when you have a cold, your sinuses are clogged, so your sense of smell is involved. So you've got a sense of smell that needs to go along with the sense of taste. So if you've got a cold, then you're going to have a harder time tasting the food that you're eating. So sometimes food doesn't taste as good when you don't feel well. All right, let's move on to the sense of balance. This is controlled by your ear. Your ear has three components. The external outer ear, it's also called the auricle, and the external ear completes at the tympanic membrane, which is your eardrum. So from the auricle to the tympanic membrane is the external ear. Your middle ear contains air and auditory ossicles. Those are the little bones you're going to learn in the next section. And then the inner ear has detailed carving of the temporal bone, and it's a fluid-filled area, and that is where your sense of balance takes place. So balance includes two different senses. You have a static equilibrium and a dynamic equilibrium. Static means moving. Static means still, stationary. So your body knows when you're standing still and upright, and dynamic, it has to do with your movement, and all those are sensed within your inner ear. And you can read that portion in your book, but there's a lot of details. I'm just going to move on past that. We're going to move on to the sense of hearing. We're also including the ear in this. It is the auditory sense. The auditory sense, sound that you take in, is just a series of waves that travel within a medium. and the medium can be moving through air or water even. The larger the wave, the louder the sound. The more frequent the sound waves, the higher pitch it sounds to your ear. So if you take a physics class, you'll learn a whole lot more about waves. Sound waves are captured by the auricle of your ear. Okay, that's the outer part of your ear. And then those sound waves move then to the tympanic membrane at the base of the ear canal. And that's starts the sense of hearing. Now there's a star here, so what I want you to remember for your test is this chain of events where the sound waves move from the air and the parts of the ear that are included. So get your book out and study this section on the movement of the sound waves. They start with the vibration of the tympanic membrane, that's the beginning, and then that tympanic membrane converts the waves from the air to vibrations of the membrane, and then the vibrations transfer into the middle ear. Remember, the middle ear had 3 ossicles. This is them. There's the malleus, the incus, and the stapes. So the vibrations transfer from one bone to the next, and they are connected with synovial joints from one bone to the next. They're tiny little bones inside your inner ear. And then once they leave the stapes, the vibrations travel through a series of membranes. You've got an oval membrane and a round membrane, and there's fluid within the inner ear, and all of that finally creates the action potential. But go back in your book and look at that, and make sure you study that before the test. So for sense of vision, just wanted to give you this little information here. Charles Darwin, who is often called the father of evolution, and I know that's an erroneous title for him. He really did not discover evolution, but people try to coin or claim that about him. But anyway, he wrote in his famous tome or book, The Origin of Species, back in the 1800s. In his book, he included this statement: to suppose that the eye, with all of its inimitable contrivances for adjusting the focus of different distances, for admitting different amounts of light, for the correction of spherical and chromatic aberration, could have been formed by natural selection, seems, I freely confess, absurd in the highest degree. So he's basically saying here that to say that the eye came about because of evolution is ridiculous, because there's so much detail included in the eye. So we'll use class time to focus on the eye, and you'll complete the rest of this module with a dissection of the eye next week.